Okay, we are still in 1.4. In this final video, we're going to do a couple more examples with parallel and perpendicular lines, and then we're going to talk about something called curve fitting or modeling, and look at how understanding how the equation of a linear as a line, a linear equation works. You can model something and use it for prediction. Okay, so going back here to the second problem at the top of the second page of your notes, write the slope-intercept equation. So right there we know that what we're looking for is a slope-intercept equation. So our answer needs to be in the form of y equals mx plus b. Right here, this is slope-intercept. So what are we given? We're given that the line that we're looking for goes through this point, 3, -2, and it is parallel to another line. Now I think sometimes problems like this we get a little confused. We're talking about two different lines. So the line that we're looking for and the line that it is parallel to. So the only thing we really care about this is any information that it gives us about the line we're looking for. And we're told that it's parallel to the line we're looking for, so what do we care about? We care about the slope. The line that we're looking for is parallel to this one, so it needs to have the same slope. So the only thing we're going to use this equation for is to find the slope. Since they're parallel lines, the line we're looking for is going to have that same slope. Once we have that slope, we have a point and we have a slope, which means we can go back to the point-slope equation that we were given at the very beginning of 1.4. It was the second thing we talked about, point-slope equation. Plug in the point, plug in the slope. We've got our equation, and then we just put it in the form that it asked for, which is slope-intercept. Okay, so we said we're only going to use this line to determine the slope. Well, how do we know the slope when we're given an equation? We put it into slope-intercept form. So we need to solve for y, and then once we solve for y, the other side of the equation will have mx plus b if it's a line, which this is. Okay, so to solve for the y, we first need to subtract 3x. So we subtract 3x from both sides. We get 3y equals -3x plus 5. We still need to divide by 4 in order to get the y by itself, and we get y equals, dividing the -3x by 4, we get -3/4x, and then dividing the 5 by 4, 5/4. Now what do we care about here? Again, the only thing we care about is that this is parallel to the line that we're looking for. So that means they have the same slope. So the only thing we care about here is what is the slope? -3/4. We don't care about the y-intercept or anything else about that line. We're done with it. Once we've determined the slope is -3/4, the line we're looking for also has a slope of -3/4. So now we're going to use that and use the point, and I'm going to scroll up. So go back to your first page of notes. Right here in this big box, we have the point slope equation where we can plug in xy, x1, y1, and our slope, and that gives us our equation. So that equation, if you're looking at your notes, you can probably see them both at the same time. Y minus y1, y1 is -2, so that's +2, equals m, -3/4, and then x minus x1, which is 3. So we've got an equation for our line. Remember, these are equivalent. This is an equation for a line. The x's and y's that make this true will plot a line that is our answer, but we were asked to put it in slope-intercept form. That means we need to solve this one for y, which is right there. We need to subtract the 2. We need to distribute to get rid of parentheses. So I'm going to kind of do that in one step. It might take a couple steps for you to get this, and that's fine. Distributing the -3/4, multiply it by the x, we get -3/4x. Then we also have to multiply it by -3, so that gives us +9/4. But then we're also subtracting 2, which is the same as 8/4. So we have 9/4 minus 8/4, which is a +1/4. So the equation that we're looking for, and hopefully you can read this here, y equals -3/4x plus 1/4. Okay, I'm going to erase that circle so I can see the next problem. Okay, the last problem. Write the slope-intercept equation for a line that passes through 3, -2 and is perpendicular to 3x plus 4y equals 5. Notice that this is exactly the same question except for one word. What is that word? Perpendicular instead of parallel. So going back to our definitions at the bottom of the last page, perpendicular lines, the slopes are what? Opposite reciprocals. We have the same line here. We dealt with this line a while ago and we said its slope is -3/4. So we'll just call that M1. The line that we're looking for is perpendicular to that, so we're going to call that M2. And we did some examples of this on the prior page. To get the slope of the perpendicular line, we take the opposite. So instead of negative, it's going to be positive, and reciprocal. So instead of 3/4, it's 4/3. Once we have that slope, this is the slope of the line we're looking for. This is a point on the line. Once again, just like we did here, we're going to plug it into the point slope formula. We have the same point, so y equals 2 equals, but we have a different slope, 4/3 x minus 3. Okay, simplifying, distributing, and then subtracting the two. I'm just going to kind of go through those steps all in one step, but if you need to write out the intermediate steps, that's fine. Distributing 4/3 times x, and then I take 4/3 times -3. Notice the 3 would be 3/1, so the 3's cancel and I get -4, but I'm also subtracting 2 from each side, so altogether I have -6. So here is the answer to the second question. Okay, let's move on to curve fitting. And you're going to have some word problems in your homework. And so hopefully this example here will help you understand how to tackle those. But, if you run into questions, let's keep this discussion going. You can post them in the discussion forum and talk through, you might see some things that look different than this. But this is a good example of how you can use what we've learned about linear equations to predict the future. Okay, so the first thing this said, well, let's just look at the information, and then you'll see I've already created a graph because I didn't want to waste the time on the video to do that, but you can pause the video and draw your own graph when we get to that point, and then move on, but that way you're not just watching me draw it. Okay, so we're given this information, so let's just make sure we understand what we're given. The cost of health insurance. Following table lists the average monthly cost to workers' families, health insurance for various years. So notice that it starts in 2009. It goes through 2014. Well, here we're in 2020, right? So a few years have passed. And we can see the cost has gone up, which probably you would have guessed that if you've, not just insurance, but lots of things have gone up, but definitely health insurance has gone up. Over the last, this would be 10 years ago, 2009 would be a little over 10 years ago. So, you would expect that today, probably health insurance costs more than it did back then. So the first thing that we're asked to do, and this is what I did before I started the video, plot the data points on a coordinate plane. So notice that I made a graph here. I didn't extend this out in the negative direction because we're not talking about negative years or negative dollars. I just started with the origin here at 0, 0, through the x-axis and the y-axis. The x-axis starts with 0 for 2009, and notice they put that on the chart here too. 2009 is the year 0, and then each year after that, we go up to 5, is 2014. And then the cost to workers is the y-axis, and I labeled that. That's an important thing to notice that I labeled, because sometimes these labels are going to communicate information that otherwise wouldn't be there. In this case, this is actually true dollars. Sometimes things are given in like thousands of dollars. It is a cost. So just putting that information there, labeling your axes, is very helpful on word problems. Okay, so the question here, and I plotted the points. So for year 0 or 2009, the cost was $293. So I went up here. It's a little bit less than 3,000. You can see that it's right there underneath 2,000. Maybe it even should be a little bit higher if I was really to scale. If you're using graph paper, you might be able to do this a little neater. year one, the cost is $333, so that's like a third of the way between $3,000 and $4,000. So I tried to estimate that. Year two, $344, a little bit higher. $360, $380, we're getting really close to that $400 here. And in year five, it crosses over and it's just higher than $400. So hopefully my graph is somewhat close to that. If I had a grid here, I could make those maybe a little more accurate, but it basically represents those numbers. So if you haven't yet, pause the video and on your notes, go ahead and draw a sketch that represents this paper, or represents this graph, this information in a coordinate plane. Okay, so the question that this first part ends with is, do you think a linear equation would be a reasonable model to predict future costs? So based on this data, does it seem like, what this is asking is, does it seem like this is following a line? So if we connected these dots, do you see how that's almost a line? It kind of has a little bit of a tail here, a little bit there, but yeah, I would say that's pretty close to a line. If when you connected the dots, you got like just a really funny shape, maybe it looks kind of like an N or a parabola or something, you would answer no. But I would say in general, it looks like this is kind of a linear movement that we see as we go from year 0 to year 5. So the answer there, I would say, is yes. Okay, the next question says, model the data with a linear function. Okay, this is what you're learning to do here, and this is what you need to know how to do for homework press questions. How do we use the data that we're given to model it as a line? So what you're going to want to do is take the first point and the last point. So the ordered pair for the first point, and remember we're using 0 through 5, so 0 and the y value is 293. And the last point is year 5 and 402. We're going to write the equation of a line that goes through those 2 points. So this is going back up to the first page of our notes. We did a problem like this where we were given 2 points and we were asked to write the equation. So just pretend like this is just like, it was our third sample that we did. Write slope-intercept equation of a line through, and then it had -3,7, -1, -5. Do you see where I'm at? We're going to do that same thing, but with these points. I'm going to go kind of quickly since we've done it. First, I'm going to calculate the slope. So on the top, we take 402 minus 295, or 293, and then we divide by 5 minus 0, or just 5. Okay, so if you do this, make sure that you do that subtraction on top before you divide by 5. So you either need to use parentheses or hit equal before you divide by 5. I get 21.8, so that's my m. So when I'm writing my equation, y equals m, 21.8, x plus, now my b is y-intercept. If you just look at the graph at point 0, I am at 293, so that is my b. Okay, so we've done step 2. Okay, so looking at the very last question, it says use the function to predict the cost to workers in 2023. So you first have to determine, well, what year is 2023? And you do that by subtracting 2023 minus year 0, which was 2009. That means when we get out to year 14, if we kept extending this graph out and got to year 14, that would be 2023. And then go back to the equation and plug 14 in for x. And when you do that, you get this equation. Okay, and forgive my handwriting here, but follow order of operations, do the multiplication, then addition. This is your answer, and make sure that you label that. The predicted cost in 2023 is $598.20.